Hey Global Impact students, this is Mr. Ellinger. This lesson is on the quadratic formula. Our learning targets are we want to solve quadratic equations using the quadratic formula, and we want to determine the number of solutions by using the discriminant. Some essential understanding for you for the lesson. A quadratic equation ax squared plus bx plus c equals 0 can be solved by a formula that gives values of x in terms of a, b, and c. The real solutions of a quadratic equation show the zeros of the related quadratic function and the x-intercepts of its graph. Background for the lesson. Unlike the other methods we've looked at, the quadratic formula can be used to solve any quadratic equation. So here is the quadratic formula. So to solve a quadratic equation, ax squared plus bx plus c equals 0, we use this quadratic formula. X equals, so our solutions are going to equal negative b plus or minus the square root of b squared minus 4ac, the product of 4a and c. That's all under the radical. And all of that whole expression is all over 2a. So negative b plus or minus the square root of b squared minus 4ac all over 2a is the quadratic formula. So we get our a, b, and c from our equation, substitute those values into the quadratic formula, and simplify to get our solutions. So where does the quadratic formula come from? Well, here's a proof, if you will, of the quadratic formula. It's actually not really a proof, but it's the derivation of the quadratic formula, and it all comes from our standard form of our quadratic set equal to 0, okay? So if we start off here with ax squared plus bx plus c equals 0, remember, we're solving for x, okay? So we're trying to isolate x on one side. So we're going to divide through by a, because we're trying to solve for x. So we divide everything by a, so we get x squared plus ba over x plus c over a equals 0. Then we're going to rewrite so that all of our x terms are on one side. So we subtract this c over a to the other side, so we're left with x squared plus b over ax equals negative c over a. Then we're going to complete the square, so we're going to take the coefficient on x, we're going to divide it by 2, and we're going to square it, so that's where this comes from, and we're going to add that to both sides. And then once we do that, we can write the left side in factored form as a perfect square trinomial. All right, so that's what we do here. And on the right side, what we did was we combined like terms by getting a common denominator, okay? So we squared this, got a common denominator of 4a squared, and then combine those two fractions into 1. Then we take the square root of both sides, undoing the square on this side, so we are left with x plus b over 2a. And then the square root of the right side, we have a plus or minus, and then all this big radical here. And now if you notice, once we get that factoring, once we complete that square and get that factoring done, we have just one x term. So then we subtract b over 2a to the other side of the equation. So we're left with x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a after we simplify that radical a little bit. And you'll notice we have a common denominator here of 2a in these two fractions. So what we can do is put them into one fraction. So we get negative b plus or minus the square root of b squared minus 4ac all over 2a equals x. So that's where it comes from. It comes from, again, taking our standard form set equal to 0 and solving for x. And you can see here, a couple of the tools that we've learned in this unit here, completing the square, solving using square roots comes in handy to derive that quadratic formula. Here's an example of using the quadratic formula. The quadratic formula is not that difficult to use in terms of we just have to identify a, b, and c, substitute them into the formula, and then the simplification part is where it can get a little messy, but it's just some basic algebra here. So if we want to solve our equation 2x squared minus x equals 4, the very first thing that we have to do is write it in standard form. So we will subtract 4 to the other side. So we got 2x squared minus x minus 4 equals 0. And if you were to try to solve this by factoring, you wouldn't be able to do so. So here we have another technique that we can use to solve this. So we identify A, B, and C. A is 2, B is -1, C is -4. Here's our quadratic formula. We substitute all of those values in for A, B, and C. Notice here with the -b on the quadratic formula, what's going to happen is whatever value you plug in for that b, the result is going to be a sign change on that value. So when b is -1, after we substitute in that -1 here, the result's going to be a positive one. So, be careful with that sign there. So we have 1, and then we have plus or minus the square root of b -1 squared minus 4 times 2 times -4. Use your parentheses when you're substituting values into a formula, especially this formula, so you can keep track. There are a couple different places where we can make sign errors. The one I just mentioned, and then this over here, lots of sign errors take place here. We got a -4 here all the time, and you're going to multiply that -4 by the two values that you substitute in. So that's another place where we can run into problems. But this is what the formula looks like after we substitute our values of A, B, and C in. So what we do is we go ahead and start simplifying, okay? So under the radical, we will wind up with a single number here under the radical. So -1 squared is 1. -4 times 2 times -4 is positive 32. So we're going to have 1 plus 32. That's where the 33 comes from. And then from here, we're going to simplify. We got 2 times 2. So we got a 4 in our denominator of our formula here. So after we substitute everything in and multiply everything out that we can, we're left with 1 plus or minus the square root of 33 all over 4. Now, we're not going to use our calculators here to calculate this radical. So we're going to simplify this radical if we can. And remember, the way we do that is we try to break up that number 33 into a factorization of a perfect square number and a non-perfect square number. But 33 is not divisible by any perfect square numbers. Okay, like 4, 9, 16. So this cannot be simplified. So what we do is we can leave our solution like this if we want. What they did is they took it a step further and they showed the two solutions here. We do 1 plus radical 33 over 4, and we do 1 minus radical 33 over 4. So whether you separate it into two separate fractions or leave it as one fraction, either way we know that there are two solutions, and we know there's two solutions in this one because of this plus minus. Okay, and we could check our work here. We always have a check. We could use a graphing calculator to graph this equation. You have the calculator do the x-intercepts or the zeros for us, and then we can see if we get the decimal equivalent or decimal approximations of those values. Okay, so we can use our technology to check our work. All right, so here's another example. Last example, we got one solution. Gosh. In the last example, we got two solutions. So here's one where we're going to get just one solution. So our equation is x squared plus 6x plus 9 equals 0. So the very first thing, identify A, B, and C. Next step is to substitute A, B, and C into the formula. And again, use parentheses here. Notice B is 6, so when I substitute it into the formula here, I wind up with -6. So I calculate 6 squared, that's 36, minus 4 times 1 times 9, that's minus 36 all over 2. 36 minus 36 is 0, so I get -6 plus or minus the square root of 0 over 2. Well, the square root of 0 is 0. So really I'm just left with -6 over 2, which is -3. So here I have one solution. Okay. Now, what does it mean? What do the number of solutions mean graphically? Okay, so remember, one of the techniques that we have to solve a quadratic is to solve by graphing, and we look for the x-intercepts. So the interpretation here, when we get this one solution from the quadratic formula, that's the only place where our quadratic intersects the x-axis. And so this is going to be a case where this parabola, here's -3, this parabola is going to come down and hit the x-axis and then go right back up, okay, something like that. It's going to have one point that's on the parabola and on the x-axis. Okay, it's not going to come down through the x-axis. It's just going to come down and touch the x-axis and go back up. So its vertex is on the x-axis, and that's the only solution that we have. The previous example, we had two solutions. So our quadratic, when we graph it, is going to, come down, go below the x-axis, and then come back up through the x-axis to get our two intercepts. So the vertex would be somewhere below the x-axis. Okay, so a quadratic equation can have two real solutions. For example, x squared equals 4. It can have one real solution. An example would be x squared equals 0. Or no real solutions, x squared equals -4. And in our next lesson, we're going to look at what do we do when we have no real solutions. In the quadratic formula, the value under the radical symbol, the b squared minus 4ac part, tells you how many real number solutions exist. So in the first example that I did, b squared minus 4ac was greater than 0, and there were two real solutions. In the second problem that I did, b squared minus 4ac equaled 0, and there was only one real solution. So this b squared minus 4ac thing, it's called the discriminant. The discriminant of a quadratic equation in the form ax squared plus bx plus c equals 0 is the value of the expression b squared minus 4ac. So here, the part under the radical is what's called the discriminant, and the discriminant tells us how many solutions there are going to be in our equation. So without even taking this all the way to the point of where we've solved the equation, we can know how many solutions there are going to be by the value of the discriminant. And here's the relationship between the discriminant, the number of solutions, and then the x-intercepts of the graph of the related function. So I was just mentioning some of that stuff in the previous example. The solution, the number of solutions tells us how many x-intercepts there's going to be. So the value of the discriminant can give us that clue. Okay. So here you can see in this table the different situations. If there's two real solutions, we could have a parabola opening up that intersects the x-axis twice. We can have a parabola that opens down, intersecting the x-axis twice. If we have one real solution, the vertex is going to be on the x-axis, whether it opens up or opens down. And if there's no real solutions, then the parabola is not going to intersect the x-axis at all, whether it opens up or down. So one question that I was thinking is, why does the discriminant tell us this information? Well, if you think about the formula, the whole quadratic formula. Okay, so there's the quadratic formula. If this value under here is greater than 0, then that means that there are going to be two square roots that you can get. So we will have a negative b plus whatever that value is and a negative b minus that value. That's where the two solutions come from. If the value of the discriminant winds up equaling 0, we're going to have negative b plus or minus 0. So the result is going to be that value, negative b, whatever it is, over 2a. So that's where we get the one solution. And then no real solutions in the discriminant means this is less than 0, meaning it's negative. And right away, if we have a negative number under a radical, that means no real solution. So that's the implications there. Okay, so if I wanted to determine how many real solutions there are in each equation, all I have to do is focus on the discriminant to make that determination. So in my first equation here in A is 2, B is -3, and C is 7. So if I substitute those values into the discriminant, I would have -3 squared minus 4 times 2 times 7. So I'm going to have 9 minus 56, which is -47. So a negative value would tell me no real solutions. Okay. And over here in B, first thing I have to do is collect all my terms on one side. Identify A, B, and C. So A is 1, B is -6, and C is 5. So substitute those values in. I get -6 squared minus 4 times 1 times 5. -6 squared is 36. -4 times 1 times 5 is -20. 36 minus 20 is 16. It's a positive number greater than 0, so we have 2 real solutions. And the implications here, if I were to graph the quadratic, and this isn't the actual graph, but the graph would look something like this. In the first one, no real solutions mean it doesn't intersect the x-axis. 2 real solutions means it's going to intersect the x-axis twice. Okay? So that's the quadratic formula. First thing, we have to remember the quadratic formula and what it is. And then, using it is not too bad. We just have to identify the values, plug them in, be very careful with our signs as we're simplifying the expression, and then know what to do with the plus or minus and the square root to, get to the point where we have our 1 solution or our 2 solutions or our no solutions. Like I said, in the next lesson, we're going to talk about what we can do when there are no real solutions. All right, up until this point in time, you've probably been told in most of your math classes that if you get a negative number under a radical, then that's an error, that's a problem. It's not really a problem, you just haven't known about this. There's another type of number that you've not been exposed to. So we're going to take a look at that in our next lesson. So I hope you guys have a great day, and we will see you the next time.